Good morning, everyone. This is Cassie Stumo. I'm the marketing specialist here at EAC. We will begin today's session with an introduction of EAC. Then Todd Liebenow, EAC's technical account manager, will be diving into how you can use Creo Simulation Live to accelerate your analyses in the early design phases. Everyone should be receiving a recording of the session pending any technical difficulties. Please feel free to drop questions in the chat and we'll answer them after the presentation. I'll now pass it off to Shannon to give the EAC introduction.
All right, thanks, Cassie. Hello, everyone. My name is Shannon Wilson, and I'm one of the Associate Account Managers here at EAC. I just wanted to start a quick overview for those on the call who may not be as familiar with our company and what we do. Our mission here at EAC is to transform the way companies design, manufacture, connect to, and service their products. We are the #1 solutions provider for PTC in the country, something EAC is very proud of. We have experts in 22 areas of product development and are located all over the U.S. with our headquarters located here in Burnsville, Minnesota. We offer our customers everything they need for product development, such as service lifecycle management software, which helps you create and manage service documentation, product data management software, Windshield, ThingsWorks, Navigate, and our customizable EAC productivity apps, which helps you manage internal product data. We implement the Internet of Things and augmented reality into business strategies to jumpstart initiatives around digital transformation and connecting all things in your company. We assist with design and engineering projects like FEAs, simulation, reverse engineering, and proof of concepts for our customers. We also offer webinars and PTC certified training courses for continuous learning. We are also a commercial reseller of Formlabs, offering the Form 2, which is an SLA desktop 3D printer that delivers a high-resolution parts and prototypes for as low as $3,500. So please keep this in mind. We really have a variety of tools to help your organization save time and money throughout the product development process. And our job here is to help you excel at what you already know how to do best. I will go ahead and hand it over to Todd, who can talk to us about the new and exciting simulations technology. Todd?
All right, sounds good. So you're looking at my screen, so we'll just continue on with the slide deck here. I promise not to have too many slides. How much fun the point is for everybody. We want to get to the good stuff, the actual live demonstration. So first up, let's talk about some of the challenges relative to simulation, right? So a lot of times there's a desire to do simulation, but oftentimes it doesn't get done, right? And here's just a quick overview of some of the reasons why that happens, right? You might need to consult an expert to get it done, right? So you might have to go find somebody else in the organization or even outsource that to get that simulation set up and done, and that takes time and often doesn't happen because of that. A lot of times you might have to use a simplified version of the model, right? So that's one of the things we talk about when you're doing your analysis setup is preparing the model so that you can use the model that you have, maybe a simplified, but to kind of strip down some of the details so you can actually get it to run in a reasonable amount of time. And then another thing is this process is iterative, right? So you're looping through a lot of different design variations and changes and a lot of what ifs and, oh gosh, let's try that, and going in different directions. So because of this, and this is just some of the reasons why simulation or analysis doesn't happen, it's just a challenge to get in, right? So there's just a plethora of reasons why it often doesn't occur. So Live is a new, and it's cool because it actually fits into that niche, right? What we're talking about early on in the design process, because it's easy to use, it doesn't, and it's really sort of, you're going to get accurate results. It's accurate results, but it's easy to use and it's fast, right? So what we're doing is we're using design models. Simplification, you can certainly do simplifications if you want, but it's not required. You don't have to sort of dumb down the model to simulation, and it's done in that same sort of environment. And you're probably thinking, yeah, maybe I've heard this before, because the speed with which this all happens, right? It's live in real-time result, effectively real-time results as you're going through your design iterations and making changes. So again, what we're looking a new tab inside Creo 5, the live simulation, and we've got sort of a little bit different setup in the interface. We've got a simulation tree, very similar to what you might recognize from Creo Simulate. But we've got the model tree set up here with our simulation features and the model tree here, and it kind of breaks that up into that portion of our navigator in the window. The things we've got here, we can add different simulations, we can set up our constraints and stuff, and then we've got tools to look at the results. So what does that actually mean? What can we do with this tool? So simulation live capabilities. So we've got structural and modal type simulation run, and these are going to basically be linear results, linear solvers. So we're talking not or plastic. Talking about structural, thermal, and modal type analyses with this linear solver, because where in the design process is going to be used. It's early on, we're concepting. If we want to do more in-depth studies later on using either ANSYS or we can do that, but this is a tool that fits in a specific portion or phase of the design process. It's early on while you're doing your concepting. So what do? Right, we set up our model. Right, in this case, we're looking at a thermal analysis. We set up every condition for convection, conduct, those types of things. You set up your receiving or generating heat in the model, and then we go ahead and run it. Right, we don't need to do right. So this happens seamlessly in the background. There's capabilities for doing that. So it basically takes all of that heavy lifting of that whole analysis out of the way, right? So I'm just considering or wanting to understand what's happening to my model, how it's going to perform based on the design constraint boundary conditions that I put on the model. And you're able to get results. So when you're doing simulation, you set it up on it. We'll show you that live here in just a couple minutes. It's really quick as far as getting the results back. So again, just kind of talking about some of the specific details in this unified environment, right? So you're running this in of Creo, and you've got a breakout here of the tree. So again, just a deep view of that. We have our different analyses. You can have multiple different analyses inside the model, and here we have the body constraints, we have loads, and then we have another type of simulation here. So this is a structural simulation. We have a modal simulation, and you can do all of those things. Sort of one at a time. You can't necessarily combine them. So we're not talking about doing a multi-physics kind of thing here. If you need that type of thing, that's going to be some more of the ANSYS tool set that will allow you to do that. And we can certainly talk about tools as well. So again, touched on the simulation live tab, the simulation tree, and multiple simulations. So I think we've covered everything that's on that slide. Some additional capabilities. This is not chart, so you can do assemblies. Consider doing their analysis towards Creo or something like that. So bonded assemblies, different types of assemblies as far as the constraints and how you put things together. The other thing that's interesting about this is the solver runs continuously. What does that mean? What that means is as you do your design changes, it's going to update the results on your model. Now you can certainly turn that off if you want, but action with the solver. So add model, and I'll show you that here in a minute. It's going to update that whether that's a displaced or a temperature or type result dynamically up to date as you. So from there, you can leverage the information that you're setting up here in Create Live. What does that mean? So the loads and constraints and other things that you might put on the model here in Simulate Live, those can be used downstream in a more complete Creo Simulate tool. So if you wanted to run sort of activity studies or something like using Creo Simulate, you don't have to do your work. You don't because it's going to show that information that you've in the Simulation Live tool. Last bullet point in the slide talks about DEX, which is PTC lingo for Design Exploration Extension. And what that's talking about, or what that capability allows you to do, is to make changes. So instead of making separate backup copies of things or suppressing and resuming features and stuff like that, you can use the Design Exploration tool to variants of your design, and it'll keep that information all inside of one part. And then you can simply toggle back into that particular design variation as needed. all the information is still going to be contained inside the part, but you don't have to have multiple different copies of that are saved off in different folders and do all that kind of. I think we've done a webinar, specific design exploration. If not, certainly create one, and if there's further questions on that, we can certainly talk about that. This slide talks about results capabilities. So again, looking at this, we have the display options, whether you want to see the model in a deformed state or in the different types of fringe plots or contour band, or looking at things like probes. So that we've got here is basically analysis features. So I'm going in and putting a little probe on the model to have it report back. What's the stress at this location? What's the temperature or displacement at this specific location? Also have it display where the model minimum maximums are. Right. So the typical things that you're interested in when you're doing a simulation, all those tools are here inside the Simulation Live capability. Different ways to look at the results rendering. It's just talking ways to display the results of the model, whether that's a tone or banded fringe plot or contour plots or things like that. And of course, for deformation, you want to see how the model is going to move. So there's an animation capability for you for that. Kind of winding things down another slide or two here, interactive results. So this is sort of looking at results. We've got the ability to show things here. We're showing in this case definition. You can control whether you want to see this little legend displayed or not up in the upper right-hand corner. Dynamic query, so you can take the little probe over the model and have it report back views for whatever item it is that you're displaying as far as results. You can have these persistent probes. That was the items that we had up on the previous stay open. And you can toggle those display on and off via the standard analysis feature section in the ribbon. And again, the min-max highlights, and finally you can create an HTML report from this. So there's sort of a standard web page template. It's certainly modifiable, but you can kick out a HTML report of the simulation, downstream use or sharing out through the organization. So what's the point of all of this, right? So the idea here is to get the simulation tool involved earlier in the process, so you can start making better designs based on your design criteria. Feel for what's happening. The idea here is we want to try and minimize the life cycle time, get to a better product sooner, and that effectively translates into a lower life cycle cost. Decreasing time to market, right? So the idea here is we want to get to a better design early on by doing these simulations up front. Again, if you need to do further, more detailed or involved studies, available downstream process. Increasing quality. See, if you're doing simulations on things, you're going to get a better idea of what's happening with your model as you're doing the design, so you can get your job of the target as far as what you're doing a process or what your design model is supposed to do. And obviously they reduce the product development cost, because if you can do it quicker with a better result, that's obviously a better solution. Okay, so a bunch of slides. I'm just going to go ahead and kill out PowerPoint. Let's get to the point here where we're showing you how this stuff all works. So I've got a couple of different studies set up here for you, and we'll step you through the process of what it looks like to use the Simulation Live tool. So in this case, this assembly open up, and the first thing I want to do is to focus just on one individual part. So let's go ahead and open up this guy right here. We'll open up this specific part and kind of get an idea of how this looks. So what we want to do is look at this model. We're going to step you through the Simulation Live tool. I'm going to go ahead here, select the tab, and what that's going to do is load up the Simulation Live library. It takes just a second here. So now we've got the information or the tool set available for me to get my model set up. So from a conceptual standpoint, what we're going to do is we're going to hold on to this part down here at this bearing location, and then we're going to apply a couple of loads up here to this bearing location, and then these 3 bolt holes up here on the front portion of that. Just like with any other simulation, you need to make sure that you have material properties assigned, and in this case, we do have materials already assigned to this part, and you can certainly edit that. You'll see this is the same material definition dialog box that you're used to seeing either in Creo Simulate or in Creo in general. So a good modeling practice is to assign that as you design the part, but if you didn't, you can always apply it here while you're doing your Simulation Live. One other thing I want to bring to your attention is setup thing right here on the drop down. There's some performance options. So you have some information that you can specify here as far as the simulation quality. So there's a trade-off here between the speed and the accuracy. So in this case, I'm going to go for more accuracy, and you'll still see that it's going to run fairly quickly. But the idea here is what we're specifying here actually with this little slider is how much memory card are we going to allocate for the solution process. So what's actually happening here is we're using the video card memory to do the actual computation. That's why it has run continuously in the background. So we're going to keep that while we're making changes to the model. So you can set this accuracy anywhere that you like. I believe it starts off at something on the order of like a 0.5% down here. We're going to go slide this accuracy all the way up top to increase this accuracy of our solution. Okay, so let's get to the process here. We've got the simulation set up. In this case, it's going to be a structural simulation. The other options that we have here, we can go ahead and set up a thermal modal simulation. So that's where we access the different types of simulations that we can do. In this case, we're going to go ahead and set this up with a constraint at this location right here. We'll go ahead and grab that surface, and that's to be locked down. So we're holding on to the model at that location. And we see that nice little set of icons that pops up. For those familiar with Creo Simulate, you're going to recognize those as the constraint icons with translation and rotation 3 degrees of freedom, or X and Y and Z. So that's our constraint. The next thing we'll do is we'll apply a force. Right? We're going to go up here and grab this cylindrical surface, and I'm going to go ahead and ensure the right units. So we're going to use newtons in this case, and look at my coordinates here. I want to make sure that I'm applying that in the right direction. In this case, it's no sense to plot in the Z direction because that would be axial along that bolt or that bearing hole. So we're going to use the Y direction and the Y and the Z direction to apply the load. So we're going to say 1200 newtons in the Y direction and 600 newtons in the Z direction, and then that applies that load in the direction. I'm just going to reorient the model here a little bit. So typical setup stuff for simulation, right? So we'll go ahead and do that. Again, I'm going to toggle back into the right unit system here, and I'm going to select my reference as that, and just grab those other two cylindrical surfaces there. And again, we're going to apply a load, 1,000 units in the Y direction, negative 1,000 newtons there, and negative 500 newtons in the Z direction. Okay, so that's it. So that's enough, right? So we've defined typical simulation features tree. We have materials, we have loads and constraints. We're set to go. Let's go ahead and run it. So there we've got some results. That's the point of, I took this model and set it up with the very same loads and constraints inside of Creo Simulate, and got very, very similar results, but it took something on the order of 4 minutes. So again, we're seeing almost instantaneous results back from this. So that was nowhere near any 4 minutes to get those same type of results back. So then the next thing is, if there aren't any questions, I'm just going to keep going. The next thing is I might say, well, what if I wanted to make a change? What if I wanted to add some additional geometry or move some things around in the model? How would that affect my simulation live setup? Well, so we can go back here to the Model tab. So we're going to continue to do some work here. I've got this little sketch here. So take a look at this right here. Maybe I want to consider adding a stiffening rib that goes between the locations. So I've got that sketch already defined. Just in the interest of time, I'm going to go back then and create a trajectory rib using that sketch. Okay, so I've got a couple of different line segments in that. I'm going to go ahead and specify some values for that. I want that 5 millimeters wide. And standard kind of functionality for the trajectory rib, I'm going to add draft to the side of that. And I'm going to add rounds to the bottom of that as well, to the top of that. And I've just gone in and created that set a pair of trajectory ribs between those two locations of the model. We'll accept that. And from here, right, so we can go and create that. And now, because that station is running live in the background, just that quickly, I can see the results or the input adding that additional piece of geometry to the model. So again, the idea is I can look at different design variations very quickly. I don't have to do any meshing. I don't have to do any of that other, analysis kind of stuff other than set up the model and then take a look at the different design features that I might want to include. So I'll just take a 5-second pause here and check and see if there's any questions or comments that anyone might have.
I don't see any questions in the queue yet, but we'll see if any come in pretty soon here.
Okay, sounds good then. The next question probably might, it's great for, but what about an assembly? Or maybe let's talk just briefly about that design exploration thing that I mentioned a couple minutes ago. So where do we find that and how does that work? So if I went back here to the files section, and if I look at the managed session, right? So we look at file, managed session. We're going to go look at this design exploration session. We can start that. And for demos, I just use the default name here, but provide a name and put it in a description. Use this design exploration session for different changes and things you might do in the model, right? Like that rib that I just added could certainly be added there for that. I'll just take the default name. And what that does is it pops open a secondary model tree, a checkpoint tree. And this allows you to come back in and do different things in your model. So for example, if I'm back to the flexible modeling tab, that, hey, I want to move some things around or make a change to something, I can do that, right? So I could come back in here and say, well, if I wanted to go ahead and move something, I can right here, and it's going to temporarily turn off the solver. And what I can do then is come back in and pick on that circuit and that. I want to move a whole bunch of geometry in one direction. So I'm just going to go ahead and pick a reference direction that I want to move that relative to. We'll pick that surface there. And what I want to do is reorient that so I can pick this right there. So now it's going to let me move that using the dragger. So I'm just going to go drag this thing out. And you see as soon as I move that, I get a value that's up. So I can use that flexible modeling tool and move that guy over 3 millimeters. And as soon as that's done, it's just going to make sure it can actually move the there. We'll go ahead and accept, move that to the new location. We'll regenerate that, and then what we'll do is we'll just save that point in the model. It's so that what that'll do is it's moved at 3 millimeters and it's done moving, right? It's going to go ahead and start doing that simulation background for me right away. So we'll save that as a checkpoint. And I'm just going to double click that and provide the information. We're going to say moved boss and rib 3 millimeters, right? So give it a name. You can plug in keywords here, give it some comment. It's going to make a little timestamp for you. So just go ahead and make any design changes that you might want to add in your design exploration section, and then you can toggle back to that quickly. So if we went back here to my entry checkpoint, I can double click that. What I'm going to do is move that surface back 3 millimeters to where it started from. And so it gives me the ability to have all of my different design variations inside that one model, different backup copies or, you know, suppressor resume features happening inside of this design exploration session. So I'll go ahead and exit out of that, save that design exploration. When you're finished with the design exploration session, the model will be left in whatever checkpoint state you specify before you leave that, right? So all of those other options would still be there, and you can have branches and different options inside the design exploration tool. But it'll remain whatever setting you had upon exiting that tool. Okay, so that's a little bit on design exploration. The next thing is if we look at this, the standpoint, it's going to be the very same for this. So again, go to the live simulation. In this case, we've got our model set up here. We're going to go back and take a look at some of the things we have set up here. Analysis. We have constraints set up right here. On both sides of that, we've got a shaft that runs through there. And in this case, we've got the loads applied here. And again, with the setup options, I want to make sure that that's all the way up here as far as the accuracy. So I get more accurate results. And we'll go ahead and run it. Right, so in this case, we're looking at a structural simulation for this overall assembly. And again, consider how long this would take if you're going to do this in something like a Creo. We're almost back, and we can start to look at how the model is going to behave as far as the loads and constraints conditions we've applied. So other thing to look at, I didn't really look at the results. I mean, I just showed the fringe plot and kind of bypassed that. I should really better that. So let's talk about that. From the results options, here we've got the different items we can display. Von Mises stresses, different list of things that you're going to want to see when you're doing a structural type simulation. In this case, if we look at a deformation, we'll see something that looks like this. If I want to animate that, right, we can go ahead and set that up as an we have the ability to control the speed and the scale of the deformation, so you can sort of grossly exaggerate that, or we can actually see the true deformations of that. So that's what that model is going to do when we apply the loads in that fashion. From a deformation standpoint, we go back and look at some of the other here. In case we're looking at deformation, we went back. You can look at that as the stress on the surface, or you can do that sort of a composite, and that'll give you sort of how this stress is actually flowing into the components of the part. Right, so it's a kind of like an X-ray view or X-ray vision inside the part there, so it's happening in the model. Again, so surfaces you can it goes on for different that are displayed here in the fringe plot, so you can control or play what's being shown on those surfaces of constant stress values. And if you want to show the min and max, right, I'm just going to give you a couple little circles here that show you here's the maximum value at that located model. Over here on the other side, here's going to be your minimum value right here. So that's the global max and the minimum. If you want to go back and look at other things here as far as the simulation is going to do is on different locations in the model. So say I want to know what's happening right at this location right there. It's going to go ahead and give me that and keep that stress, or keep that as I work through the model, keep that analysis play or analysis results shown on the window for me. So let's see, other things we might want to talk about. The simulation report, you go back and basically generate that HTML report, and I'll go back and make some screenshots and capture the information and compile that together into this web page. So it's built out this summary. Here's the table of components that are in there. It gives me the analysis data, boundary conditions specified, loads and constraints, and gives me the sort of web page report of that model. Again, there's some hyperlink at the top of the model. Grab the slider and go all the way back to the top. So here's that to that. So it's just a page that you can use to kind of generate some results and then share that out with other people, so you don't have to drag the model or drag the computer over to where they are, or bring it to your desk and show them what you got for results. So the thing that I think is really cool about this is that it is so fast, right? It's to do the same type of model in Creo Simulate or another tool. It's a little bit of setup. It's the same setup, but the solution time is quite a bit longer, right? So they've integrated solvers inside of the Creo Simulate or the Creo environment to do the simulation, and it just runs incredibly fast. Like I said, that one model ran on the order of 4 minutes versus something like less than 10 seconds to get me some almost virtually instantaneous feedback on the results for the load case that I've applied. So it makes it really easy to use that early on in the design process. So hopefully that means that you'll be able to use that more regularly in your design efforts. So with that, that's what I wanted to show from the Creo Simulate Live standpoint. Certainly open questions if there are any.
Thank you so much, Todd, for that demo. I'm not seeing any questions at the moment, but if you still have questions, or if you think of any after the webinar is over, please reach out to us. I also want to mention that there will be a short 5-question survey that will appear as soon as we shut down the webinar. So answering these questions really help us deliver better content and presentations to you, and we really appreciate your feedback. So please go ahead and answer those for us. You can find upcoming webinars on eacpds.com/events, or if you'd like to see any previous webinars to date, you can go out to our webinar replay library to watch them. Those of you on the call will get the recording of the webinar shortly. And again, thanks for getting on today, and have a great rest of your day.